Okay guys, we're going to be looking at calculating conditional probabilities and evaluating the independent use of the two-way table. Okay, so I am going to try my best and make this as neat as possible. All right, so well, I'm going to let you read that and then give you a second, pause the video, read it, and then we can go on. Okay, so knowing the information that we have, we can now fill out this chart, right? It says what cell in table 1 represents a hypothetical group of 1,000 students at Rufus King High School. Well, for a hypothetical 1,000, that would mean that this total right here is equal to 1,000. So we'd have to say cell 9 is equal to 1,000, which means cell 7 and 8 have to total 1,000, and cell 3 and 6 equal 1,000. All right. Number 2, what cell in table 1 can be filled based on the information given about student population? Place these values in the appropriate cells of the table based on this information. Well, since we're looking at total male and females here, it tells us that there are 58% of the school's population is female, which would mean cell 3 is going to be able to be filled out, and because of that, we can also, well, let's go ahead and fill that in. Cell 3 is going to be, since it's 58%, you would have to say that is 580. Okay, 580 students. What else do we know? We know that 40% of the students are involved in one or more of the after-school athletic program. Okay, so that is going to be 40%, and that would be here. This category is involved in after-school program, which means cell 7 can be filled in. So we're going to put, what was it, 40%? So that was going to be 400. Okay. Now, I'm going to copy and paste that as we're going to be using that to answer questions on the next page as well. So let's go to page 2. And, oh my goodness, what's happened here? Let's unlock that. Let me move this up. And then we will paste our chart. Yeah, that's still there. Okay. So if I paste it, and we should have it popping up there. And we will continue to fill it in as we go here. Move it. We'll put it right here for now. Okay. It says, based on the cells you completed in exercise 2, which of the following probabilities can be calculated and which cannot be calculated? Okay. So since we've already filled in some of them, we also know that cell 9, we didn't write it in there. Let me go ahead and write that in there. Cell 9 has to be 1,000 as well. Okay. Even though we did not put it there. So if cell 9 is 1,000. Cell 7 is 400. That means cell 8 has to be 600, because I told you that cell 7 and 8 has to equal 9 and cell 3 and 6 has to equal 9. Well, if cell 3 is 580, that means cell 6 has to be 420. Okay. So, now it wants to know, A says the probability that a randomly selected student is female. So if we're just randomly picking, we're going to look and see what is the probability that that student will be female. And when we're talking about probability, you don't want to write percentages, okay? Because that's saying what percent is. And we're just saying what's the probability. So you're going to write that as 58, because that's total of cell 3. Okay. The probability that the student participates in an after-school athletic program is going to be 40 hundredths. Okay. The probability that a randomly selected student does not participate, well, do we know that in an after-school program that is male? So that would be, we got two conditions here. Okay, this is the whole calculating conditional probabilities. The probability that the randomly selected student who does not participate in an after-school program is male. So does not participate and male, that would be cell 5. We don't know that yet. There's no way to know that. Okay? Now, this one says that we will, the probability that a randomly selected student participates in the after-school athletic program. Well, do we know that one yet? Randomly selected male student that participates in. So that's going to be cell 4. We don't know that one yet either, right? I'm just writing these in. So we would just write, no, we do not know. We're going to have more information to be able to tell whether or not we have a male that participates in an after-school program. Okay. So I'm going to, once again, try to screenshot this if it's going to work. And we will move it over to the next page and use it for the rest of the questions. I don't know why all of these have now gotten crazy. All right. We're going to look at the athletic director indicates that 20, so we're going to be given more information so we can fill in this chart here. It says the athletic director indicates that 23.2% of the students, notice it's a percent, we're not talking about probabilities here. We know 23.2% of the students at Rufus King are female and participate in after-school program. So if we know that they are female and they participate, that's going to be cell 1. So we're going to write in 23 or 232 because we're looking at a hypothetical 1,000. So we would just have to multiply that. Okay. Now, we also consider the cells now 1, 2, 4, and 5. This is number 5 of table 1. Identify which cells represent students who are female who participate in after-school programs. Okay, well, females that participate in after-school programs. So that would be cell 1 and just cell 1, right? We're just looking at females who participate in after-school programs. Okay, that would just be it. And what cells of the two-way table are of male who do not participate? So males that do not participate would be cell 5. Okay. But by looking at that, we could go ahead and fill in the rest of our chart, right? Oh, we were supposed to do that in number 1, so let's go ahead and fill that in. So number 4 up there. 232, we would just say 580, the total, minus 232, and that would be, 348? And if we know cell 7 is 400 and cell 1 is 232, then that's going to make cell 4 168. And since that is 168, we know cell 6 is 420. We would subtract that, and we get 252. Hopefully that's pretty simple. Once we are given that extra information, we can fill out the rest. And it's just knowing how to read a chart. Okay. All right, let's go to page 4. All right. So it's talking about, we have this hypothetical 1,000 table. And it can be organized in ways to make it possible to answer various questions. Okay. And we can investigate whether female students are more likely to be involved in after-school athletic programs. Okay, so it says consider the following events. Let A represent the event of a randomly selected female, or randomly selected student is a female. Okay, so let not A, or the complement of A, the opposite of A, that would be the complement of A, not A. That would represent a randomly selected student that is not female. Or that would be the same thing as a randomly selected student is male, right? So let B represent a randomly selected student that participates in an after-school athletic program. Well, the complement B, or not B, is the same thing as saying a randomly selected student that does not participate in an after-school athletic program. Okay. Now, if we say let A or B, this is considered a union. Okay. A or B. That means it could be either, right? Represent a randomly selected student is female or participates in an after-school program. So they are either female or they participate in an see that or there? Or they participate in an after-school program. Now, A and B is what we call an intersection, A and B, and it has to be both. Represent a randomly selected student that is female and participates in an after-school athletic program. So all we have to do is look at the intersection there of where a female student marks or is also intersects the column of participating in an athletic or in an after-school athletic program. So or and this one's going to be much wider, the union, because it's either or, right? As long as she's female or in an after-school program. And intersect, it has to be and. Both of them. Both conditions have to be satisfied. So, based on the description above, describe the events in words, okay? So we're going to describe these events in words when we're talking about not A and B. not A or B, and so I'm actually going to, let's see here. Okay, so if we say not A, if you remember what we just talked about, that said not A, that would mean that it is male, because A was female. So A would be male, and or not B. So or not B would be what? B was talking about playing after school or being in after school events. So if it's not B, that would be a male or someone who does not participate. So I'm just going to put not participate. I'll put Alright, we're just going to leave it. I'm going to put not part or part for participate. Alright, A would be female. And not B would be not participate. Okay, that's what those two would, if we're looking at the probability, that's what we would look at. Female not participating. So based on the above description in table 1, determine the probability of each of the following events. So A, if we go back to our chart here that we now have filled out, okay, let me go ahead and create the screenshot and carry it over so we have it. Alright, so A is going to be simply the female, right? That's all we're looking at is the total female. The probability that we would pick a female. So if we look at that, all we have to look at is cell 3, right? Because that's the only thing that's talking about the female. So if we're talking about the probability, we would say that there is a 580 over 1,000. That would be our probability, which ends up being that's a decimal, guys. 580 thousandths or 58 hundredths. Okay, so B is going to be our male. No, I'm sorry. B is not male. B is the participants of after school programs, and we said that was 400. So we're going to put that over 1,000, which is going to be the same as a probability of 4/10, 40 hundredths, or 400 thousandths. That's all the same thing. Now, if it's not A, that's simple enough. All you would have to do, since you already have that probability, is subtract it from 1. Okay, or you could say not A would have to be the male, and that would be 420 over 1,000, which is equal to 420. And what I said earlier, you could just say 1 minus the female, because that's not the female. 1 minus that, and that's going to be something that you're going to have to see later on, and that would equal 0.42. Okay, so same thing. All right, let's keep going, and I think I can just let me move this up again. So we're looking at not B, which means B was to participate in a after school activity. Will not be would mean those that do not participate in the activity. So let's bring our chart back in here. It seems like every time I post or paste something, it gets bigger and bigger. All right, so let's look at B was participate. So not B would be those that do not participate, which would be 600 out of 1. Now, I'm not sure why it's doing that now. Out of 1. Sorry guys, don't know what's going on here. I can't find my mouse now. There it is. Let's go with stop. Out of 1,000, so that's going to equal 0.60 or whatever you want to call it, 6/10. Okay, so A or B. That would mean female and or participates in a after school activity. Well, to do that, you're going to have to do some adding here, because we need all the female possibilities and those participating in an after school activity. Okay, so the females are going to be 232. Okay, but it could also be the 348, right? So really we could just look at the total of females at over here, so 580. And then what's the other category? We can't just add the total of cell 7 here, because that's those that participate in the activity, because we've already counted that 232 in it. So we would just add cell 4 to it, because that would include the other, and that would be 748, which would be as a possibility or a probability 0.748. Notice you can't just add both of the cells totals, because you would double count your cell 1 if you did that. Okay, so A and B, all we're doing is looking at an intersection of females that participate, and that would be 232 out of 1,000. And you notice that I already done the out of 1,000 right here for the previous one. 232. Okay. Now, determine the following values. The probability of A plus the probability of not A. Well, what's the probabilities of getting an A, a female, or a male? Well, 100%, right? If those are the only two options, well, we're talking about probability, so we don't want to talk about percentages. But yeah, we're going to have probability of 1, I guess, would be it's going to happen. It is sure. We could call it, it also means 100%. So, well, what's the probability of plus B plus the probability of not plus? Same thing. Or not plus, not B. It's going to be the same thing, because you're accounting for every possibility, those that do participate and those that do not participate. And those are the only thing that we question people on. Okay. Page 7. I'm going to have to pause this and try and figure out what is going on with everything. Okay guys, sorry about that. Let's try it again. It says another type of probability is called conditional probability. Okay, and that's pulling apart the two-way table, and that helps to define the conditional probability. So if we just are looking at the female row, We would suppose that a randomly selected student is female. What is the probability that the student or the selected student participates in an after-school athletic program? This probability is an example of what is called a conditional probability. This probability is calculated as the number of students who are female and participate in an after-school athletic program, or the students in cell 1 divided by the total number of the female students. So what you're doing is you're not looking at it out of a 1,000 scenario here. You're just looking at it as a conditional statement, which means you can only deal with the total in cell 3. Okay, so let's go on to page 5 where it asks us to do things. Describe 2 conditional probabilities that can be determined from the following row in table 1. So here we're looking at the males, not the females. So what we're going to have to do is, did I not? I don't think I put the questions on the other one. Okay, so let's just look at this. What can we decide based on just this table? Well, we can look at and remember this always has to be random. Okay, it's a random male. That what? Well, we could say that participates. Okay. The other option is a random male that what? Does not participate. Those are the 2 conditions we can find from this. Now on 12, describe 2 condition probabilities that can be determined from the following column. Well, this would have to be a random what? A random participant that is female and a random participant that is male. Okay. If you have the total, that's the part that has to be random. Okay. And then you're trying to decide what's the probability of it meeting the other condition. Okay. That they are either female or male. And then that's the reason why it's the random participant here. Okay. Page 9 says, determine the following conditional probabilities. A randomly selected female student, what is the probability that she participates in an after-school athletic program? All right, I think I still have my chart here that I can paste in. All right, so let's see what they are actually wanting here. Remember, we're only going to be looking at the certain conditions that are presented in the question. Okay, so it wants to know a randomly selected student. Well, that randomly selected tells you that it's going to be out of cell 3, which is 580. Okay, whatever else they're talking about is going to be based out of cell 3. What is the probability she participates in an after-school athletic program? Well, that would have to be cell 1, which is 232. And that's going to equal, if we divided that, we would get about 40. Okay, or 40%. All right, randomly selected male. Well, we're going to look in cell 6. That's going to be out of 420. And we want to know that he participates in an after school. So that would be cell 4, which is 168. And then that would equal, that also equals 40. Okay. Now, what about a student is selected at random? So the total students, okay, what part is that going to be out of? Well, how many students are they? There's 1,000, both male and female students. So what is the probability that this student participates in an after school? Well, we would look at cell 7 because that's all the ones that participate. And that's going to equal the same thing. Okay? Now, if all three of these, males that participate, females that participate, and the entire school that participates, think about this question. Do you think that female students are more likely to be involved in after-school athletic programs? Well, no, because the percentages were the same, or the probability. Probability was the same for females, males, and therefore it has to be for all students as well, since those were our only two options. Okay, so yeah, there's not any more likely that they're going to participate than a male. Okay, what might explain the concern female students expressed in the beginning of this lesson about the problem of assigning practice space? Okay, so I don't think we went over that, but the whole reason why they did this, we didn't talk about it at least, was that one of the female students was saying that maybe they don't have enough room to practice, and that they should have more because they have a more probability of doing an after-school activity, athletic activity. So, do they have? Why might they have thought that? Okay, if they actually have the same probability, why? So let's go back and look at our chart. The only way we could reason that they may think that is because of this cell 3 here versus the cell 6 here. Okay. That would mean that it just so happened that they were randomly chosen, okay, 1,000 students basically, and you would have 580 females and 420 males. So that would be the only way we could say, well, that's the reason why they said that they need more, is because when chosen, they had a greater number of female participants in the study. Greater number of female participants in the study. That's the reason why they may be able to come to that conclusion. Okay. And I think that's it. Yeah, sorry guys for the problem in the video. Hopefully the ones going forward though will be much better when I'm not dealing with this computer. All right.